All right, in this video, we'll be looking at the proof of the substitution rule. Like I said in the first video about substitution, really it's all about the chain rule. So let's review the chain rule, and that's what we'll start with in the proof of theorem 3.2.1. All right, so if h and g are differentiable function, then the derivative of the composition of h with g is the derivative of h times the derivative of g. All right, so here's the theorem that we're trying to prove. If I take u to be g of x, we need to show that this integral here and this one give us the same answer. So what I'll do is I'll assume that I have an antiderivative for f. So assume that h is an antiderivative for big F. So this means that h prime is equal to f. Then I'm going to look at the two sides of this equation. If I look at the left-hand side, let's look at the right-hand side first. Apparently, I've been confusing so this means right-hand side. I'm looking at the integral of f of u. I know an antiderivative for f. I know that h is it, and so that's just going to be h of u plus c. And then when I'm done integrating, I'm going to plug in g of x. That's what we do when we apply substitution. All right, so I know that this right-hand side here would give h of g of x plus c. I need to prove that the left-hand side is the same. So I need to make sure that this right here is an antiderivative for this huge thing. All right, so let me take this derivative. I mean, if you notice, that's exactly what we had above right here. So this, by the chain rule, is h prime of g of x, g prime of x, and h prime, we said by assumption that that was f. I mean, that was the only thing we knew of h. All right, but so when I take the derivative of this function, I get exactly what I have in my integral. So let's write this carefully. H of g of x is an antiderivative for f of g of x, g prime of x. And so when I integrate that big function, and that's, by the way, what the left-hand side was, then I need to find one antiderivative and put a plus c. Well, we have one now. And so I get h of g of x plus c as well. Now, if you notice, the right-hand side gave me h of g of x plus c. The left-hand side gave me h of g of x plus c. Since these are equal, I've just proven that the left-hand side is equal to the right-hand side. All right, so really the point here is when I expanded both sides, I got the same thing. Good.